In section 7.4, we're going to be learning about isosceles and equilateral triangles. So we'll start by talking about isosceles triangles. We're going to label a bunch of stuff here, so I would just draw a big triangle in your notebook and go from there. The most kind of key feature about an isosceles triangle is that it has two congruent sides. Another important part about an isosceles triangle is their base angles. So the two base angles here would also be congruent. We call this third angle here the vertex angle. We would call this bottom side, the one that's not the congruent one, the base. And then we would call the two congruent sides the legs. So I'd definitely make sure you have all this written down. So this is going to lead us to a new theorem that we can use in some proofs called the isosceles triangle theorem. So if we have a triangle and if we know that AC is congruent to BC, then we can assume that angle A is congruent to angle B. So if we have two congruent sides, we can assume that those base angles are also congruent. The reverse or the converse of this also works as well. So if we have a triangle and the only information that we have is that angle A and angle B are congruent, like in this diagram, then we can assume that those legs are congruent. So we can assume that AC and CB are congruent. So we're going to look at a diagram here and answer some questions using that theorem. So in this first part here, I'm asking, is AB congruent to CB? I have a bunch of stuff labeled, but I don't know that AB and BC are congruent. I'm not given that just in the problem. I'm able to assume that they're congruent because since those base angles A and C are congruent, that whole big triangle ABC is an isosceles triangle. And if those base angles are congruent, then I can assume that the legs AB and CB are congruent by the converse of the isosceles triangle theorem. Part B, I'm asking, is angle A congruent to angle DEA? And here, yes, since AD and ED are congruent, that's marked up in the diagram, I can assume that those base angles, angle A and angle DEA, and that small triangle are also congruent by the isosceles triangle theorem. So one more theorem, it's not going to be used as frequently, but an important one to know. If a line bisects the vertex angle, so again, remember, bisect means cuts that angle in half. So if a line bisects the vertex angle of an isosceles triangle, then that line is also the perpendicular bisector to the base. So a perpendicular bisector means it's hitting it at a perpendicular or 90-degree angle, and it also cuts that base in half. So looking at this in a diagram, if we have that triangle and we know that AC and CB are congruent, so it's an isosceles triangle, and we also know that angle ACD is congruent to BCD, since we see that, we can assume that CD is bisecting that angle because it cuts it in half. Then we can conclude that CD is hitting AB at a right angle, so CD and AB are perpendicular, and AD and DB are congruent. So that base was then cut in half into two equal parts. So we're going to use all those theorems to kind of help us solve some algebra problems, which we haven't done in a little bit. Here I have this diagram and I want to find the value of x. I see that AB and BC are congruent. That's marked up, so we know we're working with an isosceles triangle. I also see that ABD and CBD are congruent, so that means that DB would be an angle bisector. So that's going to be useful information as we go throughout this problem. So again, since AB and BC are congruent, we have an isosceles triangle, and those base angles A and C would be congruent. Since we know that angle A is 54, angle C has also got to be 54 degrees. Also, since BD is bisecting angle ABC, again, we know that because those two smaller angles are equal, so we know that big angle is cut in half. We now can also conclude that BD is perpendicular to AC. So CDB would have to be 90 degrees. Now, kind of regrouping here, looking at our diagram, seeing what's marked up, I could see here that in that triangle there that I have highlighted, I have 2 out of the 3 angles. And we've looked at problems like this before. When I have 2 of the 3 angles, I can solve, because I know that no matter what triangle I have, no matter how I draw it, all the angles in any triangle is going to add up to 180. So I'm going to set up an equation like that, 90 plus 54 plus x equals 180. Combine like terms and solve for x, and I get that x is equal to 36 degrees. So again, kind of a longer problem. None of the algebra itself is that difficult. It's just we're kind of using these new theorems that we're learning to be able to set up the problem. So again, make sure that these theorems are neatly written in your notes, and that'll kind of help you work through these kinds of problems. Very last thing that we're going to talk about today is equilateral triangles. Equilateral triangles, all the sides are congruent. That's important. And all the angles are congruent. And that's really all that we're going to write in our notes about that. So that's it.